After lots of anticipation and waiting, we are finally looking at the pH scale. So we've got our acids over here with pHs below 7, like vinegar, lemon, and stomach acid, and our bases, soap and bleach and drain cleaner, up near 14. With pH, it's a simple, straightforward calculation. We're given the equations. It's just being familiar with them. And then remembering a couple important things in terms of sig figs, strong versus weak, and remembering how to apply them. So if we scroll up even a little bit more, we've got our other important equation here. So first and foremost, this is all based upon the Kw expression, or how water ionizes into hydronium hydroxide. And since those are such small values, generally, we use the pH to turn those tiny decimals into whole numbers or into numbers with decimals. So when we do the log of something, we're getting rid of the exponent. It's a negative log because most of the time we will have a negative exponent. An important note with this, a lot of times people say that a pH of 1 or 14 are the extremes, but we can go down to a pH of 0. And it is possible in the most extreme of circumstances, based on this calculation, to even have a negative pH. The reality of that circumstance is something you would explore a little bit more in college chemistry once we can go beyond just the idea of molarity. But the math here is very simple. You plug in your value, you do the negative log of it, and to undo a log, you do an exponent, remembering that it becomes negative. We can also talk in terms of POH and OH minus. We can also do the log of all of these things. Right here, this is kind of the log version of the equation up above, that the negative log of my hydronium and the negative log of my hydroxide is equal to the negative log of 1 times 10 to the negative 14. So the problems here are going to practice all these different equations. They're pretty straightforward, just knowing when and how to use them. The important piece here is that if we have a strong acid or a strong base, they 100% completely dissociate, meaning that whatever the molarity of my HCl is, that's the molarity of my hydronium ion. Whatever the molarity of my OH or of my base is, that's the molarity of my OH, paying attention to any subscripts in there as well. But a couple important things here is that the rules for sig figs are a little bit different when we get into logs. So multiplying and dividing has its own set of rules. Addition and subtraction has a set of rules. So do exponents. So the number of sig figs after the decimal place in the pH. So if I come down here, there's 3 digits after the decimal place. Those are the digits that are significant. That number in front of it, the 3, is related to the exponent itself, and it is not considered a significant digit. And the number of significant digits in the concentration is how many should be after the decimal. So here I have 3 significant digits. That means when I change that to a pH, you'll find out that there's 3 after the decimal. There's 2 digits here, so that turns into 2 after the decimal. So just paying attention to that and knowing that's a little bit different. The other thing, and there's a whole video about this, watch this video, is that you will at times have to estimate pHs. That means you have to estimate logs, or you have to take a log and turn it into the decimal form. There's a whole video on that. This is a very quick overview of that, but the video's short. It's worth it. It's something you're going to see on multiple choice. It's also a skill that's going to happen with, or excuse me, that's going to be useful to help check your free response and understand those a little bit better. So make sure that you review this math, whether it's watching the video or just checking out the answers, but definitely think about how we can round and how we can estimate these numbers.